guarding dinner, but it's at lunch, so I've renamed it lunch. Because it was pointed out to me, it's like, why is it at lunch? Because it's egg drop X. And I'm like, yeah, okay, fine. It's lunch talk. And I got some stuff like stuck in lunch, guarding dinner, thanks. Pick up my YouTube channel, appreciate that. But I finally got some support from Sam. It was like, this is going to be a cutting edge talk. I'm like, yeah, I feel better about myself. Then he posted that. I'm like, you guys are killing me here. You're killing me. So, yeah, my name's Wolf Goerlich. I'm involved with B-Sides Detroit. I'm involved with Converge. I work with CBI. I'm involved with MISEC. And today what I'm talking about is some of the things that we've learned from the food industry, some of the things that we've learned by looking at 15 different food manufacturers, going in, getting on the plant floor, digging in and figuring out where the strengths and the weaknesses of the technology is. And I love having this talk at lunch. I love the fact, I hope did everyone get there like hamburgers and whatnot? We're good? Awesome, great. So hopefully you still have an appetite after this. Because I'm going to tell you why you're probably going to die. One of the things I do at CBI is I work at CBI Academy, which is 2-year programs. Young people come in, they work for us. It's an apprenticeship program, and they circle through. So in the spirit of what Jason Street was saying earlier, giving credit where credit is due, big shout out to a lot of the Academy guys who did a lot of the work that I'm about to talk about. They did the grunt work. And then also our red team, Sean Bertrand, who's also here floating around somewhere, who did the assessment side of it. So when we started talking about food industry, I thought back. When I was a wee lad, I grew up on a farm, and I grew up, hands in the dirt, pulling weeds, and chickens and cows running around, and I hated it. I was very happy to get onto the computer and get out of that. But I had some preconceived notions, right? Some preconceived notions growing up that way. I thought we're going to get out, we're going to meet some farmers who are growing the cows, and they're going to tell us how the cow becomes my hamburger. Maybe not this world, but maybe a little more high-tech, but I still thought that it was going to be more earthy. I thought it was not necessarily going to be very high-tech. I thought we were going to be talking about tractors and heads of cattle. But actually, when we started digging into it, actually some very interesting things came out. One is that the food industry today is a modern industrial complex. The food industry today has every single technology of every single company you guys are probably familiar with in their environment, and they're trying to support it, and that's what's putting food on the table. And that creates some very interesting complications, and that creates some very interesting things. If you think about food from a food supply perspective, from a factory perspective, you begin thinking about conveyors and belts and machinery and gears and cutting edges and saws and all those sort of fun things. You also begin thinking about power. Food industry is a massive consumer of power. So much power, in fact, that if you think of all the power in all of Utah, that's how much in one single year the food industry alone consumes. A power of an entire state is consumed by the food industry, which is kind of fascinating. Only thing I knew about Utah before that was that Novell was there, and Novell's kind of old, so I just dated myself. But I'm like, wow, and they also have power. And all that power goes to the food industry. The other thing to think about that, though, is what the food industry has done to contain prices, to be competitive, to be a big player, is they've taken on reclamation projects. They've taken on energy generation projects. They are a producer of power as well. So when I say all the power in the entire state of Utah is consumed by the food industry, keep in mind that also means that they are producing a lot of that power. So all the technology you see in energy companies, NERC SIP, regulations, those types of things, all applies to this field. And what could possibly go wrong with power, right? You guys probably heard of the Ukrainian. Can anyone pronounce that? I've never found anyone who can pronounce that. Don't worry about that. Google black energy malware if you haven't heard about it. In the Ukraine, they had an attack against a power plant. That was one of the first spottings of this malware called black energy, and it got in and disrupted power systems. The SCADA systems, the technology that was maintaining those generators, the leads and speeds, it got in and disrupted it. That same exact technology that's in that plant is in the food industry. Now, not only is there tons and tons and tons of power, there's also tons and tons and tons of water. The amount of water it takes to put a hamburger on the plate is in the order of thousands and tens of thousands of gallons. To wash a single chicken, it's about 1,000 gallons when the chicken moves through the plant. Now you think about the fact they're running like 1 million chickens through these plants in any given week. That is a massive amount of water. That's valves, that's controllers, that's pumps. It's all the same technology that you guys probably looked at when you were wee little and you went to the, the water plant tour, right? Oh, look, there's the valve. And then you ran around behind the security line and got yelled at. Anyone else? Like, what are you doing back there? I'm not doing anything. Just saw this lever and I thought I'd pull it. Then alarm sound. Maybe that's just me, but you guys get my point. There's a lot of technology, and all these same problems exist in the food industry. 10% of all the fresh water in North America goes to the food industry. It's not insignificant. And also along with that, so if you're a local water plant and you're in the industry or in the city, there's regs, right? City regulations, state regulations, federal regulations about what you do with that water because it's a public utility. These food providers are reclamating that water, keeping prices low, recycling that water, keeping prices low, and they, luckily for them, fall out of it, but what that means to us is those same regulatory pressures might not exist in the food industry. And what could possibly go wrong? Nenwai Bozeman, which was the dam that was tampered with, you guys see that? They were messing with the dam that was containing all that water and threatening to open it up before the manual controls were thrown in. Kind of interesting. Komori Water Company is even more fascinating. Google this one if you want to read about it afterwards. They messed with the pH balance of the water. They were able to poison the water. And when they poisoned the water, these attackers got in and were working on a very, very old system. 1983 legacy IBM mainframe they were able to get in and screw with. So two parts of that. One, 1983, that's amazing. I want a 1983 computer running my water plant. So like that Commodore that we saw that was like running the Ukrainian like auto thing. You guys see that on Facebook? I'm like, that's fantastic. I want a classic retro 1983 water company. But the other thing is, that's indicative of what we see in the water industry. That's indicative of what we see in the food industry. These are legacy systems that are still being maintained today that are many, many decades old. So food is a modern marvel. And it's built on the same technologies we run every single day, and the same problems we see every single day is what we see in the food industry. So what are those problems? What are we looking at? First, I know in this day and age we're a politically correct group, maybe not in GrrCON, but just in case anyone wants to be aware, a little bit of a trigger warning. Especially for all us blue teamers out there. What I'm going to show may be a little bit shocking, maybe a little bit surprising. Bear with me. Calculator. Every single time there's a breach, right? That's what you see. It's like, I exploited this buffer flow. I ran calculator. I blew up this CTF. Look, I can run calculator. 9 times out of 10 when I'm watching an exploit in one of these talks, they're like, I launched calculator. My labs guy is so freaking good. He doesn't even run calculator anymore. He just writes overflows. It's amazing. So calculator is where we think about all our vulnerabilities. Calculator is what we see when we see something wrong with Windows XP. Calculator is what we see when we see something wrong with a Word exploit. Calculator was even recently exploited with continuous integration, right? Jenkins had an exploit. Jenkins is the new framework that all the DevOps kids are using. Jenkins is the way we continuously deploy applications. And Jenkins, this cloud, continuous integration, brand new app, the minute they exploited, the first thing they showed was a screenshot launching calculator. Like, that is phenomenal. I want to write code so I can run calculator. But that's we kind of almost got blasé, right? Well, there's an exploit. That means someone's going to run calculator. Yeah, it means an exploit. We're going to reboot our box. But meanwhile, in real life, and these food producers, we're talking about serious impacts. The food industry alone is already one of the riskiest places to work in terms of accidents, because there's a lot of moving parts and a lot of them are very sharp. Not only that, but if you think about the high pressure, there's oftentimes explosions within these boiler systems, right? So in real life, you can talk about catastrophic failure. You can talk about a boiler system going critical, blowing up, and taking out a whole plant. Not even remotely improbable. It happens all the time. Other thing is, of course, disease. We hear about disease all the time. Things like mad cow, salmonella, all the fun things. These are Think Geek plushes, by the way. These are awesome Christmas gifts. My daughter loves her salmonella and her mad cow. She really does. But so how do you stop salmonella? Well, maybe don't order it from Think Geek. But the CDC put out some things. What do? You cook it, right? You cook it till it's 145 degrees or 160. You refrigerate it below 40, right? We're hoping that this stuff has been done before the food gets to us. And what determines that temperature? A sensor connected to a computer, connected to a network. What determines how we cook it? A broiler connected to a computer, connected to a network. Any number of these things go wrong, and then you got salmonella in the food supply. So we're beyond talking about calculator, which is why I was very interested and intrigued with this particular project. Because for so long, I'm like, oh yeah, okay, we'll stop calculator from running, that's great. And not to belittle all the other technology, I mean, we're all working hard to stop things. But when you tell me I can blow up a plant or introduce salmonella to a quarter of the food supply, I might stop and listen. So what is some of the technology we're running? Well, here's what it looks like. It is operational technology, right? So we got our traditional IT stuff over here, your corporate network, your ERP system, your production management. This is the stuff we've been securing for 20 years, 30 years. This is stuff we know and lead and bleed with. This is stuff you're going to hear about at GrrCON and other conferences. We've gotten pretty good. Maybe not great, but we've gotten pretty good. We've come a long way since Windows XP, patching and securing and maintaining these systems. Then you got your SCADA, which is all the equipment that sits between that traditional IT and your production equipment. So this is the equipment that is a OS, but it's a dedicated OS. It may be running Windows or Linux, but it's only running one app. That app is written by a company specifically for this food process. And then, once we got our traditional IT in this no man's land of SCADA systems, then we got our hardcore industrial stuff, right? RTUs, PLCs. This is the equipment that's actually moving the metal, moving the blades, moving the saws, heating, cooling, and doing everything else to get food done. And what's interesting is, for as rocky but as much progress as we made in securing IT, we've done very, very little on the OT side. I've talked a lot about software development security, and it kind of feels like software development security 5-10 years ago, where the developers all do the developer stuff, and the cybersecurity guys all do the IT stuff, and you don't really talk very much. And it's the same exact way between IT and OT. They're over there, they're doing their stuff, the manufacturing systems are running, we'll just leave them be. Is it secure? I don't know. It's running. What do you have? I don't know. And there's a massive difference between these environments. On the corporate side, it's still relatively cheap, right? Maybe $1K to $10K for some equipment. You're going to run it for 2 or 3 years. You got your IT team. You trust them. They know what they're doing. You're scanning. You're patching. It's a good life. On the OT side, not so much. We spend a tremendous amount of money to buy these things. 10K to 1 million and up. We run them, therefore, for a real long time to get the benefit back. The 1983 AIX computer running a water supply, not unusual. We'll run it for 20 or 30 years. It's maintained by the operations team, different culture, different language, different folks, different reporting structure. And don't try and scan it. Don't ever scan it. Every one of these food providers, not everyone, but just about everyone, we're going to go in and we're talking to the guys, and they will go to us and be like, "You're not one of those, are you?" We learned right away. The answer is no. Whenever anyone asks you that, are you a god? Yes, if you watch Ghostbusters. Are you one of those guys? No, if you're an OT. Are you one of those guys? No. What would they do if I was one of those guys? You know, those guys that come in and scan. Oh, no, we wouldn't do it. Why? What happened? Well, you know, the guy came in and he scanned my environment and it borked the system. We tried to reboot it. That didn't fix. The assembly line for the defeathering was down for a day. We lost $5 million. We had to ship a guy out from who knows where overnight to parachute in and fix this system. He did some magic and put the magic smoke back in, and it worked. And I will not have that happening. I cannot afford a day of downtime. Like, that's why I'm not one of those guys. And they're very concerned because these systems are very old. They're not built to be scanned, right? Our traditional IT has kind of grown up with us security guys poking it and breaking it and messing with it. OT, not so much. So it's also a whole bunch of different vendors. You've got things like Omron, HMS, Rockwell Automation, Fanuc, which is, I was pretty excited about the robots. We'll get back to them. But again, these are not Windows and Apple, right? People beat the hell out of Microsoft for years for being insecure. And people are now beating the hell out of Apple, saying, you know, I messed with your iMessage. I got your metadata. Or, you know, I can do this super elite thing on your Microsoft Office. And you're like, oh, well, we'll fix that. These guys don't hear that. They don't hear from us. And therefore, in their minds, oftentimes, we're secure. One of the big standouts, though, I'll say, is Rockwell Automation and Allen Bradley. They've been doing a lot on the OT side to come in and explain the IT security perspective of the matter and say, hey, here's some things you should think about, here's some things you should fix. So shout out to them. But in general, it's a long, long haul. And yeah, Fanuc robots, that's fantastic. There's robots, I loved it. Originally I'm like, tell me it's gonna be like Rosie the Robot or like Terminator. I had like a mental image of both pushing the cow up. So I was a little bit disappointed when it was this. But the thing is, that gray one right there, the gray one, we did this assessment earlier this year. The gray one in February had a buffer overflow. The gray one in February had a buffer overflow that allowed remote coded execution. You know what you could do with remote coded execution? You could change the safety parameters and swing it around. So you got a huge arm capable of moving 10,000 pounds with a nice sword on the end of it, right? Or a spinning drill or whatever it may be. And now from the comfort of your own home, you can hit a button, send a packet, and move it wherever you want. Again, not calculator, right? Like, whoa, death by phone. Something you don't hear very often. So we're not talking about our typical farm. We're not talking about our typical tech. It's some very interesting stuff. I'm going to pause right here and open for any questions before I talk about what we've found in this environment. Anyone have any questions on OT, how it wears together, what it looks like? Going once, going twice? Cool, all right. So we went in and looked at 15 different locations. We looked at these 15 different locations to figure out what the strengths and weaknesses were, what the real security posture was, and what could be done to fix it. I'm going to tell you guys what we found, and then I'm going to give you some ideas of what could be done to fix these environments, to guard dinner or protect lunch as it may be, as well as some thoughts of how these same concepts could apply to our environments when we're facing a little bit less life-threatening environments. One is the area that no one ever wants to talk about. It's governance. So the first thing we looked at was what governance framework are they mapping up to, right? And it's not something that's usually exciting. It's not something that's usually sexy. We'll breeze by that quickly, I promise. But of course, NIST has put out a lot of guidance, both in 53B and 82. So 53B for all the traditional stuff, we should all be familiar with that. And 82 for the OT side, which is good. It's very helpful for us because when we find something, we can say, hey, NIST says you should do this, which is much better than saying, Wolf was at GrrCON. He says, you know, it'd be kind of cool, right? A little bit more weight. So that's good. Also, in terms of NIST providing an overall framework, we can then begin to hang some of our findings on it. So I always like to start with that governance side. Next thing is breaking down what this stuff looks like. I apologize for anyone outside of the VIP row. On behalf of GrrCON, you should get a VIP ticket. There. You're welcome. All right, I will walk you through this, but the bottom line is this. We need to understand where the technology is and what it does, right? So if you follow like the life of a chicken, oh, that's a really bad way to put it. Can't believe I said that. So you eviscerate it, you defeather it, you boil it, we run it through the plant, you cut it, you process it. It's a great way of saying cooking. You package it up, we freeze it out, again, core temperatures, and then we ship it. All these are key processes. The next thing we do, right, is we lay out what valves, motors, pumps, conveyors, the water treatment system that I was talking about. Again, 10% of all the fresh water, can you imagine? All right, the water treatment system I was talking about, refrigeration, the switches and equipment. We lay out all that equipment and we map it up to that business process. And the third thing is, what is all the SCADA stuff, technical term, SCADA stuff, that's talking to all that equipment, right? And by looking at that layer, we can then, as we move forward, talk about things not only in terms of NIST, but talk in terms of things of what can be the impact. Because if you're in a manufacturer and your life is working with the shipping department, saying, you know, you got a CVS score on this computer called A567, which is an IP address of 10.10.20.58. Do you know what 58 is? I didn't know, but I think we should patch that. Or saying, you know what, your manufacturing line could go down, you couldn't ship tomorrow. What would that do? A little bit of difference. A little bit of difference. So we start by laying all that out. And we think about it in terms of the overall business process. And we communicate and evaluate in terms of the overall business process. Next thing, all right, so that's governance in the business side. Next thing is planning, project management, good old-fashioned project management. Things like scope and resources and schedule. We had a very, very tight schedule on this project. Incredibly tight schedule. We had to like parachute in on Monday and be out by Friday, which is actually kind of like how I like it. I oftentimes talk about my academy guys, the A-team. I kind of like, I want to get one of those helicopters and play like Flight of the Valkyries and like parachute them in. So if anyone wants to hire us to do that, I would gladly expense a helicopter. But we think a lot in terms of IT. Okay, who's the resources? What's the scope? What do we need? Food is different. It's a different culture. It's a different world. One of the main things I ran into right away is, oh yeah, and by the way, your plan, did you look at the birds? What do you mean the birds? Yeah, did you think about the bird flight? You're pulling my leg. No, we got to coordinate any of these plants east to west so that you're not crossing the bird migration path and introducing any bird flu. All right then, let's talk about the birds. Those types of things you would never ever think about. There's a million of them going into this OT environment that makes it very hard to assess. The type of clothing you wear, when you can come in, what the plant operations are. Special kind of shoes, the fact you can't leave your shoes after you walk through it. All those sort of things have to be assessed, and it's one of the things that makes it very difficult to do this kind of work. All right, so governance and project management. There's an old story, you guys have probably heard it. If you wake up in the morning and you eat a frog, everything else in your day is good. There's nothing else as bad as eating that frog. So there, we've ate the frog, governance and project management, which I happen to like, but it's my frog. So next thing is we got to be very realistic. We've got a really tight scope. We got to get in, we got to get out. We don't necessarily understand the environment, right? We got people who don't necessarily understand us. How much real life data are we going to be able to achieve? And this gets back to a risk approach. A lot of times in computers, when I was growing up as a wee lad and I got on the computer so I didn't have to be on the farm, I was like, this is awesome. I can make binary, right? On or off. I can string binary together and make a character. That's great. That's an A. That's a B. It's ASCII. All right, this is amazing. And we still tend to think black or white, right? On or off, do we capture it all or not? Risk-based approach is so vitally important, especially in this world, because with the amount of data and with the amount of infrastructure and whether stuff's on or off or whatnot, we're maybe hoping to catch like 60, 70%. If you can get 80% of these environments and just baseline understand them, you're doing amazing, right? Which is still pretty good, because that gives you some indication, that gives you some rules of thumb. The things that apply to this type of machine is probably the same thing that applies to that type of machine. You know, the Allen Bradley robot was down yesterday, but you assess this other Allen Bradley robot, can we apply those controls? Those types of things end up being really, really well. So if we can aim for pretty good, give us some insight and clear the fog a little bit, we're in a good spot. So I'm a big, big fan of being realistic. When we went through this environment and we're trying to figure out how we could capture as much as possible, we had some basic rules. What can we see on the wire? What can we connect to without scanning? How can we do this without breaking anything? Again, protecting the organization, keeping it available. And the way we ended up developing the plan was to parachute in and capture the packets and analyze those packets. We're going to talk a little bit more about that in a minute, but the key thing with that is then you begin asking questions like, what can you see? What segments are available? What processes are running? You know, in a kill floor, you may have like 3 or 4 different shifts, and each shift is going out to a different group, which means different machines process it and different cleaning is used. What's the difference between a cow and a pig and a chicken? All those sort of things. So trying to simplify the world as much as possible and understand those and have a really good plan going in so we can get as much data as possible, knowing and recognizing and being comfortable with the fact that we're not going to be looking at every nut, bolt, and screw. We're going to get a good insight, directional, and then move from there. All right, next thing is be creative. I mentioned packets. This was one of the most fun parts of this engagement. So if you look at, yeah, and drink lots of coffee. Okay, that should be like my disclaimer of every talk. Have you drinking enough coffee today? If you look at IT, OT, and whatnot, there's several points along the way that these devices are talking. And ideally, you got some segmentation. We'll get back to that ideal in a moment. But if you can just start with the premise of how much of this information can we capture, you can then say, okay, what does that information tell us? This is network analysis, right? Network analysis 101. There is another way you can do it, which is looking at the config file, which is logging in, pulling down the config, and scanning that file as well. Because again, scanning devices, really bad. Reading config files, not so bad. So there's different ways that you can do that. There's a company called Digital Bond. So check them out. Digital Bond has published a whole bunch of configs. So what you do is you log into your OT, you pull down the config file, you throw it to Nessus, you have Nessus read the standard from Digital Bond, you compare it, and you can vuln scan the configs that way, which is awesome. It's a great way to get some fantastic data. Only downside with that is Digital Bond only covers maybe 1/10 of what we saw. It's a very small footprint because Digital Bond is primarily made for the energy industry. So you can probably back that up and say, oh, about 1/10 of the equipment you're using is common with the electrical industry, which makes sense with the amount of power we're using. So, but check that out. They've got some great stuff. They also have PCAPs, which you can look and analyze and see what this traffic looks like. If you take those PCAPs and throw them into an analyzer, such as a passive vulnerability scanner through Tenable, you get something that looks like this. And it begins to tell you, hey, here's the vulnerabilities we're seeing on the wire. And here's our areas of weakness. So we're seeing some IP address, 10.25.2.2. You want to know who that is? No. It's a evisceration machine, I'm sure of it. So we begin to get all that information and scan it by host. And then you can also look at in terms of what the protocol is. Oh, we got some Modbus going on. Modbus is fantastic because it has a tremendous amount of vulnerabilities in all clear text. We got some Siemens client work. Okay, we can make some assessments of what that is. Some generic protocols, what have you. We can begin to see what those protocols are and backtrack to say, okay, here's the type of devices we have. We can also throw that PCAP in and build a map, which again ties back to what we're working with. So if you go to Digital Bond, you can get the PCAP and look at everything I just showed you, those exact protocols, all those screenshots came from those PCAPs. In our environment, we would parachute in and capture a week's worth of PCAPs and analyze them that way. Another place you can go is samurai.stfu.org, which has some additional PCAPs and has an entire distro for looking at OT. Some really cool stuff, similar to what they're doing with the web app, but only focused on industrial controls. So now we have all these IP addresses. Now we have all these hosts. Now we have all these information about what they're running. We can make some assessments. We got the config file about what versions they have. What we do next, and this is the most time-consuming version, but this is also something I think we've kind of lost in the security industry because we're pretty sedentary. We sit down behind a desk. What we do now is we walk the floor, right? This device, what is it? This device, where's it go? This device is the right device. We walk that plant floor and we check out physically what we've discovered logically. And you can get some great insights out of that. Not only about physical security, which is also always important. Bundle that in, can you get in? But also about things like what devices are on, what devices are off. Is it the right information? We found one particular device consistently reported the wrong name, so we were able to fix that in our data set, those types of things. So we walk the plant floor. Again, think about project management, that project management triangle, knowing that we have to have the right shoes and all this other stuff. The next thing, and this is the most painful area, and again, huge, huge shout out to my academy, is we go through and look at the release notes. So if we know this version came out in 1998, let's look at the release notes since then for versions that and look for the vulnerabilities that were identified. One of the things that's kind of a challenge in OT is these are not typically CVS scores. These typically are not published. Nessus can give you a good indication, but it's not going to give you the same indication as the manuals. The manuals have great things like, oh, by the way, here's the reset password, and it is hard-coded to blah, blah, blah. And you're like, ah, that's good to know. Oh my God, that's good to know. And So we went through all the manuals from the time these things were published up to figure out and aggregate what those vulnerabilities were and get really granular on the technical details. Another thing that I'd really like to see from this field is being able to share that information, because these release notes are tied to contracts, and the contracts is a support agreement, and there's an NDA and everything else. It's not like IT. IT, if there's a vuln, it's everywhere and everyone knows about it, and it's published on Twitter 5-6 times, and I've retweeted it. But if it's in OT, it's in one of these manuals, and pretty much no one has looked at it or thought about it. So we read all the documentation, walk the floor and read all the documentation. And then we got to communicate this to people. We run into the classic problem of information security, which is how do you communicate it to the executive team, which is why things like governance and in terms of NIST and the workflow in terms of knowing what all the technology does, that's where that comes into play. But also knowing the culture. So because so many of these things grew up in the fields, in the farms, there's still a mentality, and it's a great mentality among these plant operators, or the rugged individual. Sure, corporate may say to do that, but that's not my standard. Corporate may say to do that, but down here, we know what we're doing, right? That rugged individual who's out there, right, day in and day out, fresh off the factory or fresh off the farm and running the factory. So we also have to appeal to those silverback gorillas. And those silverback gorillas are the guys who know all the secrets, know where the bodies are buried. They're the women who don't talk in the meeting to the very last thing, and whatever that woman says, everyone's like, that's what we'll do. You know, those people. The silverback gorillas are the people who, whatever corporate says, they're ultimately going to decide what happens, because they'll go, that sounds great, and the minute corporate leaves, they're going to go, yeah, I really want you to do it this way, right? Silverback gorillas are your best friends. And we were able to have some silverback gorillas on this project. Silverback gorilla was, when we were delivering the results, one engagement, they're like, that sounds good. That language right there? I'm like, yeah. He goes, yeah, it says accelerate, blah, blah, blah. I'm like, yeah. He's like, yeah, don't say that unless you want to get your head bit off. I'm like, what? No, that's like common business language. You accelerate the paradigm. No, now I'm really kind of joking. But I'm like, what do you mean by my head off? He goes, yeah, there's a meeting, and that guy you're presenting to jumped all over this other guy because he's like, what do you mean accelerate? We're going as fast as we can. We've got all our bodies at this, right? We are working real hard to solve these problems. Who are you to tell me to accelerate? I'm like, that's really good insight. Scratch that out. So then we're doing the presentation. I'm like, yeah. And so here you see that you guys are running full steam, and we don't want to add anything to your plate because it's amazing how hard you guys are running, how much you're doing. However, if we look at this particular area, we should be able to save you some time as well as solve this problem. They're like, yeah, that's great. You guys get us. I'm like, thank you, silverback gorilla. So it's amazing if you can find those people. Those are the ones who are going to pull you aside and tell you what's really what. But no, of course, this is no surprise to anyone in this room that what we're ultimately fighting with in OT, as in security everywhere, is this concept of, it's always been that way. So yeah, it's an 83-year-old or 1983 AX, but it runs. I don't need to mess with it. So we've got to be very, very prepared to have that conversation about why it's always run that way, why the risks have changed, and what we can do differently. All right, so some findings, and I'll get to some discussion about how to guard against it. Asset inventory. We thought, hey, yeah, we'll have an asset inventory. We'll just ask for it. They'll be like, here you go. Here's what I paid $1 million for. A long time ago, I was at a financial company, and I reported to the CFO, and this was like my first real insight in terms of how not to talk to a CFO. And he called me up. He's like, blah, blah, blah is broken, blah, blah, what are you doing to fix it? I'm like, I am all over fixing it. The problem is system ABC, and we're going to fix it, system ABC. He goes, what's system ABC? And I'm thinking, system ABC is the thing you just signed $2 million PO for last week. What do you mean, what is system ABC? Why is it I did not say that, which is why I probably still have a career. But I'm like, let me rephrase that. You know the thing that makes the thing that you do possible? Yeah, that's broke, and we're going to fix it. And it occurred to me, hey, if they're paying $1 million, that's nothing to them, right? That was a 15-minute meeting. Things have moved on. And it's the same thing in the food environment. I was reminded of that when I was like, hey, do you have an asset inventory for that $1 million equipment they bought? And they're like, what? No. So one of the hardest things to do was to build that inventory, and it was actually one of the things that we gave out of the project. This is what it looked like when we broke it down. A lot of Frick, HMS Entron, 8%, not that much actually. Some Opto, almost all of it, 76% Rockwell AB. 76% equipment Rockwell AB. They're the Microsoft of this environment. If we can get Rockwell AB on board with securing their stuff and communicating to people, we're going to make so much headway in this. And I was very pleased to see with one location, Rockwell AB actually sent out representatives to say, here's our view on security and here's what you guys could do. I'm like, this is great. Because they speak that manufacturer, that farm equipment guy, very, very well. It's all about translating information security. Aging technology. We expected we see really old stuff. We didn't expect we see really, really old stuff. So 40% of it is 16 years or older. Another 40% is 11 or 15. Very, very little is new, right? Only about 8% has been developed in the past 5 years. So only about 8% of it is got web tech, only 8% of it has new stuff. So those types of bones that we all talk about here, not so much. That 11 to 15 years represents a boom that happened in the manufacturing food industry about 15 years ago where they were very profitable. They invested, they built a lot of plants. You guys may remember that's Windows 2000, 2003, XP. They bought a lot of Windows 2000, 2003, XP. That stuff's not going away. It's everywhere. XP is everywhere, and they're not ripping it out. Why would you rip it out? You invested it, you rutted it, it's working. Come on, it's always worked that way. So we're going to be seeing XP in Windows 2000 for a long, long time. Segmentation, nope. Talk about culture. Talk about culture. When we talk at, Cisco World, or we're in school and we're like, hey, networking guy of the future, thou shalt segment. Networking guy's like, I shall segment. And the book says, thou shalt segment to contain broadcast traffic and keep things on their own segments. And they're like, I shall segment to contain broadcasting traffic. So then we go and we're like, hey, are you segmenting? They're like, we are absolutely segmenting. Like, good. How come I can see everything? Well, what do you mean? Of course you can see everything, but there's no broadcast. Okay, but you're segmenting. We're segmenting. Can I see your ACLs? Sure, here you go. And sure enough, any to any is the default, right? These guys that put in segment, they hear segmentation as, give me a VLAN with an IP and make it routable. So in many of the environments, it is any to any. In many of the environments, well, the OT is segmented. It's not necessarily segmented like we would think from a security perspective, which is a very big concern, especially when you get to the next thing. We went into this, we thought we'd be looking at vulnerabilities, right? Like clear text, remote code, product manipulation. It's actually even worse. Only about 2% SQL injection, which is good. Again, most of the stuff, not new. But tons and tons of product manipulation. 19% of the systems have plain text passwords. A lot of those passwords are published in the service guide and service manual available for anyone to find. Remote code execution, 5% of the systems, you can log into them, you can mess with them. You can do bad stuff. And that's not good. Not good at all. So, can we scan it? No. Because if you look back here, right, denial of service, 9%. 1 in 10 are vulnerable to DOS. If you do like a simple IP scan or a Nessus scan, you will be knocking stuff over. So, again, remember, segmented, but you can get packets over there. It's a problem. All right, and lots of plain text passwords. So, we talk about OT and we talk about shining a light on it. We were like, hey, what are we going to do with all this stuff? We integrated in with the overall program. We integrated in with NIST. We talk about what systems need to be changed. But ultimately, we need a solution, right? We need some way of guarding this food supply. And that's what I'm going to talk about for the rest of the day. Some of it's going to be pretty intuitive. Some of it may be counterintuitive. Part of it is, why it may be counterintuitive, is we hear this all the time. How many blue people are in the room? Blue team? The blue team folks? Yay! The rest of you guys all red team? Really? There's a lot of red teamers. I'm in for it. All right, so how many times you guys hear this, right? The red team, the criminals, the bad guys only need to be right once. But we need to get it right every single time. You guys hear that once? Twice? I heard it 3 different sessions yesterday. 3 different times at GrrCON. We got to get it right every single time. Well, maybe not. So I'm going to turn this on its head. I'm going to show maybe we don't have to get it right every single time. And it begins with a balloon. It begins with a red balloon. It begins with a red balloon that follows a path of monkeys. This doesn't make a lot of sense, but you guys ever play Balloon Tower Defense? It's a great game. You guys should play it. That should be like 101 for security teams. All right, so Balloon Tower Defense is a very simple game. The balloons follow a path, and eventually they get to the end. Now, definitely download it, definitely play it, but think about it from this perspective. If you think about that path as the way a criminal is going to move through your network, if you think about those balloons as the likelihood of a vulnerability, each one of them having an impact, we need to start putting defenses against the entire system. And when we think, well, what we need to do is defend everything, because if we only get one thing wrong, we're screwed, then you end up spending a whole bunch of time, you get a whole bunch of pushback, and we get very, very frustrated, because the guy's like, I'm not touching that. That manufacturing system is from 1983. It works great. What's your problem? So I'm going to propose a slightly different method, right? Balloon tower defense looks like this. The attack path is the path the criminals take. We want to put multiple defenses against it, and we want to realize we're not going to know our entire environment. 60 to 80% is great. We're not going to stop every attack. 60 to 80% on any given control is great. But if we have enough controls along the path, we're just maybe going to get lucky. And I don't mean that way. I mean, that's for the after party. I mean, we might be able to stop the bad guys. All right. So when we start talking about that, we start layering on those defenses, right? And putting them along the path the attackers take, popping the balloons, and hopefully stopping the bad guys. But knowing that some of them are going to get through. This is a hypothetical attack path that I'm going to walk you guys through. If you guys have seen any of my talks, you know that this is all threat modeling, right? So it looks something like this. We have an animal rights activist, or Jason Street, because Jason would do this. He walks in, he starts plugging in stuff and messing with things. And he plugs in an attack device and walks out. That attack device beacons the criminal mastermind who is remote, logs in, probes that network, hops the subnet, because it's segmented, finds some exploits, because they're all over the place, as we talked about, 1 in 10 DDoS, 1 in 5 clear text password, and does the bad thing. We want to stop the bad thing. So we start putting in multiple layers of defenses. One of the ways to think about a defense is to think about it in terms of control theory. If you think about your input and your output, we want to stop the bad thing doesn't happen, right? Because people are doing some process, and there's some control we're going to put in place. The area oftentimes we miss, and I would argue was probably the most leading indicator of a mature security program, is this, the sensor, the feedback that says, we don't want the bad thing to go, bad thing's not happening. Well, maybe the bad thing might be happening, we gotta do something, right? So keep this in mind as we talk about the controls, because all sorts of stuff's gonna happen. We don't have a good idea of what the environment is. We don't know what the attacks are. There's all sorts of crazy stuff that's gonna happen. This is robotics theory, right? You got a controller, you got a motor, you got a sensor. It's the same concept, but let's apply it to our controls along our attack path. So we select the goal. We select what controls we're going to use. We figure out what our gap is. We measure the difference between those controls. And then we set some metrics, we set some measurements. And then we educate, we communicate what the strategy is and have that feedback loop so that people know what they're supposed to do and hopefully they do the right thing. This being one of the hardest ones. One of the conversations we had was great. Do you have wireless security? We have wireless security. That's fantastic. I notice you have many open access points. Okay, but we have wireless security. Okay, I notice the access points are connected to a network that can get to sensitive stuff. I don't know why you're telling me this. We have wireless security. All right. Can you tell me about your wireless security? We've got these scanners, and they're wireless, and every day, everyone checks them in, and we lock them in this cabinet. And it's a really good cabinet. That is secure. I'm not going to argue. I could not break into that cabinet. We've got to bridge that communication gap, right, which is one of the hardest things to do. So we want to put multiple defenses across that thing, but we only want to do just the thing. We have to do the thing that gives us some feedback, that communicates it, and protects us, right, that follows that control logic. So if you think about that hypothetical attack, animal rights activist walks in, plugs stuff in, does everything, and you do your threat models, And again, if you guys see any of my talks, I'm huge on threat models because it allows us to build this path and do some good analysis. You do the threat models, you can begin to see where along those paths you can add prevention and detection. Here's some ideas that you could do. Starting with physical security, right? Keeping the guys out. When you're doing this assessment, you walk in, you see if you can breach the physical security. If you can, obviously there's a problem. We feed that back, we communicate it. I was on an engagement earlier this year where I'm like, hey, do I get a badge? Because I'm going to be here all week and I got lunch and I got to step out. And they're like, no. I don't get a badge? No. How am I going to get up past the guard and 2 swipe doors? Well, you'll figure it out, Wolf. I figured it out. It was a real fun week. But physical security is always a problem, right? So we start there. How can we improve it? Knowing that it's not going to stop everything. Maybe 1 in 2, 1 in 3? Great. At least we got something. Next thing is the network access controls. Let's add some detection prevention. Let's prevent people from plugging in anything. This is traditional IT security, but almost no one does it. Something as simple as locking down the MAC addresses for whatever you plug in. And then alerting like crazy when someone does plug in something. And making sure we've got someone who's monitoring. Again, having that full feedback loop. Someone who's sitting in the SOC or someone who's watching a sim was picking up the phone and says, do you know someone just plugged a Pony Express into, is that, I don't even know how to pronounce that, Pony. Oh, okay. Is that supposed to be there? No, it's not. We'll take care of it. Thank you. So having some good network access controls for the next step. Next, firewall monitoring and the SIM, the review. So egress filtering. Again, we all are doing egress filtering. Our OT places, no, because they haven't really thought about it. When they built it, egress filtering wasn't a thing. We were fighting about egress filtering, what, 10 years ago? Was it maybe 10, 15? It's been a while. I think IT we kind of get, we block everything we don't want to get out. But them not so much. So implementing egress filtering and putting in the intrusion detection, and then again, review. Someone's got to be watching that. Someone's got to be aware and alerted and respond when someone's beaconing out and doing something they shouldn't. Segmentation, but real segmentation. One of the nice things about doing a PCAP process where you're capturing all the packets and you align that process across different food lines and whatnot is now you've got a real-world heat map of what IPs talk to what. And a real-world communication path of what ports are talking to what ports. Implement that in the filtering and lock everything down. This alone will stop almost everything, right? Even better, again, is if you've got an IPS IDS, and even better if you have someone who's watching it and picking up the bat phone whenever anyone does something they shouldn't. And the next is, and this one's kind of the cool one, deception. Honeypots. Honeypots. They are now manufacturers of honeypots that will produce a device that looks just like a medical device, a manufacturing device, a food processing device. Put that in the environment and light it up. This is a little more advanced. You don't want to do this until you have someone who's watching and responding. It also costs some. Another way to do it is say, hey, do you have any, ICS stuff you retired? Yeah, I've got this device over here. Great, can we plug it in and monitor it and light it up the sim like a Christmas tree if anyone talks to it? Sure. So putting in ICS, honeypots in this layer, so if anything does manage to get through and scan this, you're lit up like a Christmas tree and you know what's going on. Next, host-based hardening. Windows XP is going to be around forever and ever and ever, and that pains me to death to say. One more time, it's going to be around forever. Because they've spent millions of dollars. They're not going to retire it. Another fun thing about the food industry, #1 purchaser of cereal cards. 1990s cereal cards. Biggest customer for those. All right, so technology is going to be around forever. What do you do? Host-based hardening. I've got manufacturing companies that have deployed this very successfully. They lock the box down. Nothing talks to it. Nothing gets in. Nothing gets out. It's locked down. It's hardened. It's application whitelisting, all those sort of things, which is actually really easy to do in this space because they're not patching. They're not adding stuff. It's not that people are browsing the web from it. So host-based hardening with, again, detection if anyone messes with it. It changes it. One company is doing something really cool where they are using this technology. So again, control and then disturbance, patch or vuln comes out, feedback. They're running Metasploit. You guys know H.D. Moore's law, which is security progresses at the rate of H.D. Moore finding stuff and putting in Metasploit. They run Metasploit against these box every time there's a new vuln. And if, for whatever reason, they're able to exploit that box, this Windows XP box, they issue a new hardening statement. So that's how they're patching it. And they're going to keep doing that for the foreseeable future because it's cheaper than buying patches from Microsoft, and it creates less instability. So patch, I put this last, because if you run these environments, you don't want to patch. Oh my God, don't take me down for a week. It is an option, though. It's something that we might do, but very judiciously. And if we patch, where we patch, we need to not just do the patch, right? This gets back to every single vuln report ever. Here, patch these things. They're like, thank you, I will patch these things. IT guy patches the things. Next time you come out, here, patch these things. They're like, all right, I'll patch these things. And here, patch, and they're finally like, what the heck? Why do I keep getting all these patches? I'm like, have you considered a vuln management program? You know they come out every month. And, oh, yeah, you're right. So let's not just do the thing. Let's make sure we have the process in place to do it over and over again, right? So that's the way we stop all these different things. Physical security, egress monitoring, segmentation, host hardening, patches if you need to, segmentation, et cetera, down the line, with someone doing feedback, with someone catching it, with someone raising the red flag when any of these things go wrong. That way, when the balloons hit the fan, you got a fighting chance to stop everything and catch these things, because each one of these controls is going to fail. Each one of these things I just mentioned will absolutely positively fail. 1 to 5 times, 1 in 3 times, depends on the control. This is the way we get a fighting chance. And this is the way we turn it into something a little bit different, right? The bad guys, they need to get lucky every single time now. They need to pass each one of those things and make sure my SIM guys, my SOC guys, aren't going to let the phone and catch them. We only need to get lucky once. That's where I want to be playing with that, the blue team. All right, in conclusion, because I'm going a little bit over, food. Food is a modern marvel. We got tons of electrical equipment. We got tons of water processing equipment. We got a ton of manufacturing equipment. It's all behind the scenes getting food on our tables every single day. At the same time, each one of those pieces of equipment has all the same vulnerabilities of all those industries with none of the regulations. And nothing is more personal than securing our food, right? Anyone want to get like salmonella? I don't think so. So much worse than someone running calculator in my box. Now, of course, the food supply, whenever I give this talk, someone always comes up to me and says, is our food supply safe? Do I need to worry? And the food supply has been safe for a long time. The American food supply is the safest food supply by far. A lot of that traces back to the jungle, which woke everyone up to some of the concerns, Upton Sinclair, which launched the FDA. And from a food safety issue, they do a lot of checks. As a matter of fact, I'd argue from a security perspective, we could learn a lot from them. They do a lot of checks to make sure that nothing bad gets introduced in the food supply. We need to have our own jungle. We need to have our own awakening with these OT environments so that we can step in and start addressing the technical side. We made some great progress on the process side. Now is an opportunity to address on the technical side, right? Because while nothing is more personal and fundamental than food, nothing is more personal and fundamental than securing that operational technology. And guarding lunch and using a threat model approach and using controls along that path, balloon tower, defense, and depth, is the way that the good guys, that us, the blue team, only need to be lucky once. And it's the way the red team, the rest of you guys who didn't raise your hands, you guys have more fun. It's going to be a lot more fun pen test. Come on, than running a vuln scan, you know it will be. So that's it for me today. I thank you guys for spending lunch with me. I'm going to be here the rest of the day if you guys have any questions.